Welcome, everyone. It's Mike Gibbs, and I'm the founder and CEO of Go Cloud Careers, and we're here for another episode of the Head in the Clouds podcast. You know, in tonight's episode, and I'm going to introduce people, we may talk about a cloud architect versus a cloud engineer. We're definitely going to talk about cloud engineer training and building the world's greatest cloud engineers. We'll cover some tech career guidance, and if you have questions, you can ask. If you want to know about a cloud engineer career or a cloud engineer career development or even a cloud architect job after the discussion, please ask. We'll talk about cloud engineer interview training and cloud engineer presentation skills, and we'll even talk about hybrid cloud training. Because in today's world, it's all going to be hybrid cloud versus multi-cloud. But today's thing, we have a very special night. We actually have an instructor from our cloud engineering program, and we'll introduce him soon. His name is Nathan Curry. We stole him from Red Hat because when it comes to building cloud engineers, you need to know Linux. Whether it's Linux for cloud computing or Linux for cloud engineers or Linux for beginners, Linux is one of the most critical skills for the cloud engineer. And here's why. The cloud's built upon Linux. All the world's biggest servers are on Linux, and everything you do is going to be on Linux. So you got to know Linux. And because of that, we went to extremes. We went and hired an architect from Red Hat. Someone that has 21 certifications from Red Hat and worked at Red Hat, and we stole them to teach Linux. So what's going to happen is first you'll hear from Elonzo Coleman. You know Elonzo, he's my brother. He's here every week. And you know Chris, he's my chief operating officer. So I'll let those two introduce themselves, and then we'll bring in Nathan, and I'm real excited to bring in Nathan. I see Charles here, Cloud Hired. And yeah, if you're all here, if you can give me a hashtag Cloud Hired, and give me a hashtag what your career would be. Either a hashtag cloud engineer, hashtag cloud architect, or some other career. Let us know. And also let us know where you're from in the chat box. So, Alonzo, you want to introduce yourself for this week since nobody's seen you since last week?
Yeah, well, definitely. Well, thanks, Mike. With my great friends and colleagues here, Mike and Chris, just always excited to be here. My name is Elonzo Coleman. I'm a good friend and brother. That's just like my family, Mike Gibbs and a great friend, Chris Johnson. We all work together synchronously. It's just a wonderful thing to be here every day, every week. And with these podcasts, as we keep continuing to keep rolling and growing, I just love spending time with everyone here. So right over to you, Chris.
I'm in the middle of trying to make things happen here. You can't throw it to me that fast. All right.
Well, you are the man. We know how skilled you are, so I know you can handle it.
I'm suave. I think that's how you say it. But so I want to, so I'm happy to be here. This is an exciting one. I was telling the guys behind the scenes that I think I actually kind of get to sit back and relax and let them drive the conversation this week. So that's going to be fun for me. So I don't have to do too much work. But before we move on, I do want to make sure to make everyone aware of a couple of things that we've got going on. So Mike usually gets to do this, so I'm excited I get to do it this time. So first of all, I want to make sure that everybody votes for your next boot camp, whether it's going to be Azure or GCP. And since I'm multitasking here, let me put this link in the chat box. Unless somebody else beat me to it. But there we go. So make sure you vote on the next boot camp. We're going to be doing one within another month or so. And it's going to be either Azure or GCP. So vote now and make sure your voice is heard. So the next thing I want to bring up is that we had our first live class of our Cloud Engineer Career Development Program, which officially launched on May 1st. And we've decided to extend our presale discount, although I have not updated it to get rid of the presale words. We've extended our 50% discount on our Cloud Engineer Career Development Program. So I'm going to put the link for that in our chat box as well. But those are the two things that I wanted to bring up before moving on. So
let's go to that one more thing. You know, Chris sent me on vacation last week. He said, you need a day off. So he sent me on vacation. I was on vacation and I said, we need to continue this discount for a little bit longer. I want more cloud engineers. And when we launched that first cloud engineer course today, Oh, it was so wonderful. We got to meet so many wonderful people from all over the world, and we're so excited. So, yeah, I took 3 days off and decided we have to make this accessible to some more people. So 50% off. Please, if you're looking for a cloud engineering career, now is your time. Our cloud architect program is great. And if you want to be a cloud architect, we get somebody cloud hired every day of the week. Every day. You can see from Coyote the other day. He never worked in tech, and now he's working in tech, working for AWS, because we get our people cloud hired. The whole world focuses on certifications. I don't care about certifications. I care that everybody that enters Go Cloud Careers leaves with a 6-figure job, and they're happy. That's all that I care about. If we do that, we do our jobs. Anybody can get you certified, but it's something special to build you a career, and that's all of our focus. How do we help you build your best life? So let's bring in Nathan Curry.
All right.
And you can see he's going to be a rock solid engineer, looks, walks, and talks just like a techie. And let me tell you, we are so excited to have Nathan as part of our program. He adds so much technical depth. I am thrilled to have him. Let's bring Nathan in.
Yeah, so we're going to bring Nathan in, and I'm going to leave because my camera's acting up. I'll be right back.
Hi, guys.
Hey, Nathan.
Hey, Nathan.
I like
This
to
is
think
Nathan
that
Curry.
I walk slightly better than your average techie. I'm a good walker, but yeah. So I'm excited to be here. I'm excited to, I love Linux. I want more people to be good at Linux because it's my favorite operating system. It's super exciting technology. It's very powerful. You can accomplish anything you want to with Linux, and so I don't know. I'm excited.
I'm excited too. And Nathan, one of these days, I'm going to bring you to my house. We're going to take my 64 core Threadripper system, and we're going to turn that into my normal desktop. I just need somebody that can expertly install Zoom and expertly make OBS work and make all the drivers work. And because that, you know what?
Will you let me play that piano?
Yeah, why not?
It never fails. Every week somebody talks about
Yeah.
It's because it's a beautiful piano, you know?
So Nathan's been to my martial house, and he knows that this room's a martial arts studio, and this room's a yoga studio, and this room has 30 computers in it. But I really do love the virtual background.
Let's not talk about the workout in the garage, the gym.
Yeah. So Khalid, we are thrilled to have you. Khalid joined our class today. It was his first day. He signed up 5 minutes before class, and he participated. It was wonderful. So. Nathan, you've been working with Linux for forever, right?
It's close to 20 years that I started tinkering with it. I started at Red Hat about 4 years ago and left Red Hat about a year ago. And so Linux has been I've used it as my primary desktop for a long time. But my 100% immersion in Linux started about 4 years ago, which was a huge break for me, very exciting. Because it was something I always wanted to do was stop working on Windows. But it's 15 to 20 years, I think, in that range.
God, that's a long time. I remember back in 2000, I tried using a Red Hat desktop permanently. Yeah. And then, Henry I want to get to you in a second, but I used a Red Hat thing and I tried to run VMware on my single core, 1.5 gigahertz notebook to run Microsoft Visio. And ultimately I said, no, this can't work. But now we've reached a new thing. So working at Red Hat, you get access to all kinds of training, right?
I got access to tons of training. Yeah. I don't know, if anybody hasn't looked at it, they provide, you can do they have training that goes along with their certifications, and then they have some additional training and stuff. And so, I just took advantage while I was there and got my RHCA, so I'm the Red Hat Certified Architect. I think it was 11 certs total. I took a lot of training, and I worked on Openstack, so a private cloud, and so it's I really learned a lot about how all of that technology works, how it all goes together, how you build a cloud, and I was on the enhanced support team, so we worked with a lot of like telco clients and things like people who needed fast turnarounds and stuff. And so, and a lot of those clients had like really, really big clouds, and I got to work with a lot of talented people on the client side as well. Those people really, really knew what they were doing, and so I got to see a lot of how people, architect, do change controls on such huge environments. People with like 500 to 1,000 compute nodes that are split up among different environments. How they maintain like consistency between their environments, how they test, and all those things like that. So it was a fantastic experience. Another great thing about Red Hat. I have a lot of good things to say about Red Hat, but I think it's my second favorite thing about Red Hat, I would say, aside from just getting to dig into whatever, is it's a very open organization, and so if you ever had a question for anybody, you could reach out to them. So they like. And especially working on Openstack, which is a very vertically integrated technology. You have, it's built on the operating system, relies on the networking stack, and so it's like, I would, it's like if I needed help with networking, you could reach out to these people who really, really know networking all the way down to the kernel level, to the hardware level, know how all that stuff works. I could, talk to people that their entire week worked on just like Linux services, or worked on storage, and so it's like I've got like some of the rabbit holes I went really far down. A lot of them, there's never enough time to learn everything, right? But it's like it really gave me the opportunity to see how all of those things fit together to build the platform that the cloud is on. And of course, something like AWS, Azure, all these things they're of course, they're different from OpenStack, but they're built using the same technologies. They might be using a different hypervisor, they might be using different software for each individual piece, but it's like the way that it's stuck together, the way that people have built these clouds, it's relatively similar across the different platforms.
So that's actually for the rest of the world that's not super familiar with OpenStack versus Openshift. Let me define it. OpenStack is a Red Hat-based open source cloud platform. It is run by everybody. American Express had it, GE had it for a little while, American Airlines runs it. Everybody that's anybody runs an OpenStack cloud inside of their data center. The OpenStack cloud gives all the features, functionality, auto-scaling, everything that you get in a cloud, but it leverages the organization's previous investments in technology. A cloud is nothing more than a network in a data center that's got a control plane that orchestrates where the stuff is, and it's been virtualized. That's it. And OpenStack is like Nutanix, but OpenStack is for the smart people. It's hard to use. You have to be a Linux guruji to actually figure it out, whereas Nutanix is beautiful. Click, click, click here, and you built your own hybrid cloud. And we love Nutanix, and we love OpenStack. OpenShift, by the way, which Nathan also knows, is the Red Hat standard of Kubernetes. So when Nathan's coming from Red Hat and we're talking building clouds, he's talking about building a cloud in the data center and connecting that cloud to 2 or more public clouds. And we'll go back to Nathan in that, but I wanted to make sure that, by the way, I don't have any students in my cloud architect or cloud engineering program that don't build their own cloud. Because when everybody else goes in a job interview and says, hey, I turned on a virtual machine, and they don't even know what's a virtual machine, and they call it an EC2 instance, you can say, I built the cloud. Tell me what makes you more knowledgeable on the cloud. Design and build your own cloud, or click 2 buttons on something. So there's that. Yeah. So going back to keep talking about what you've learned about OpenStack, and you have to set up the networking, the storage. Oh, Chris, do you have a question?
So I think we got a clarification here. Aside from the fact that Mike just threw out a truth bomb about you got to be smart to do this, but I'll ask: OpenStack is a Red Hat product, or it's built on
Well,
Well,
there is a there's a I mean, the OpenStack Foundation. So it's an open kind of an open source alliance. OpenStack originally came from, like, it was developed by Rackspace and NASA. Red Hat has what it's like, the official name is Red Hat OpenStack Platform. It's a specific distribution of OpenStack. Like Ubuntu has a distribution of OpenStack as well. The Red Hat one is kind of geared towards, like a lot of Red Hat stuff, it's geared towards big enterprise. It's why IBM was interested in Red Hat, is it's things when you need real muscle and real configurability, like the Red Hat OpenStack stuff. The deployment and management is very, very robust. It's a huge headache at times, but it is really, really it's a very robust distribution of OpenStack.
And it's
yeah, I
supported by
saw
Red
that.
Hat.
Yeah, I saw that
yes,
question, and I wanted to make sure we
well,
clarified
yeah,
on that point.
and Red Hat is one of one of the major contributors to all of the open source OpenStack projects, which is actually true of all of the things that Red Hat works on. It's like their model is they commit any fixes they make to their software, they commit upstream to the community. So it is a nice model. One of the good things about that, if you're getting into Linux at all, is because it's open source, you can see the source code. One of the good things about that is that you can see engineers talking about the source code. You can go on Red Hat, like the Red Hat's Bugzilla page, and see conversations about bugs. Some of the comments are private because there's customer information or stuff about like vulnerabilities, but you can still go in there and see a lot of discussion. You can go on I think it's opendev.org is the OpenStack, where they do the change control rather than GitHub. And so you can see their discussions about bugs and things like that. So everything's open, and everything is very, very well documented. And so, if you're trying to get into this world, if you find something that you're interested in, and maybe it's not OpenStack, maybe it's something else, but any sort of open source project, you can see very, very talented people talking about something that you're passionate about. It is really cool.
It really is. But for the cloud architect in training, or the cloud engineer that's dealing with Linux skills, tell them the difference between an enterprise Linux versus just your average freeware Linux, and why might an organization be interested in an enterprise Linux for their enterprise as opposed to the freeware stuff, given that it's pretty expensive?
Well, it is. Of course. So number one, the kind of obvious answer is support. There's tons to know, and so like I said, when I was working at Red Hat, they had things. There was the network experts, where it's all day, every day networking. All day, everywhere, every day OpenStack. So it's like, if you're a cloud architect or a cloud engineer, you may be working at a place, and they'll say, whoever your project manager, product manager, some boss of yours will say, hey, we need you to install X thing. We want to test this out and see how this works. And so you get thrown into into a situation where it's like, it's learn this software, make it actually enterprise ready. And so like a company will oftentimes, you get those Red Hat licenses, and then that allows them, you get support from a very, very broad range of people. So that's the very obvious one. The other one is that the way Red Hat develops their software is they have these upstream projects, so these community projects where people can get it for free and download it. That's more like bleeding edge. So those are new. It's newer software that is, it's not as unstable as like beta software, but it is new, and you'll run into these bugs. What Red Hat will do is they will for each release. So you say like Red Hat 8 comes out, or like 8.1, right? 8.1 comes out, and then they set the package versions. They grab a package version from upstream, test it all together, like so that like all of every single package that Red Hat includes in their operating system. We're talking in terms of products. There's OpenStack, OpenShift, Ceph, which is storage, right? There's like they have a JBoss server. They have all these different things, right? All of that stuff is tested together to a certain standard. And of course, things slip through the cracks from time to time. But what they've done is they've frozen the version, made sure that everything works together, and then during that 8.1 release, they will apply bug fixes. Then and at that time, since technology is always progressing and you always need like newer things, they're planning for the 8.2 release. The 8.2 release comes out, and then there are new fixes and possibly new features for certain things. So there's an incredibly robust, and this is something that is not part of my specialty. I'm not like a software engineer. I talk to some of the software engineers. They're brilliant and insane people, and but there's it's just a very robust system, like of testing and making sure everything is stable, and that for sure that you're getting a good product. And like I can't speak specifically to the degree that Ubuntu does it, but Ubuntu does the LTS,
Yes.
long-term support version, which is in the cloud. That's I think the number one distribution of Linux. It's right because it's free, but it is good. It's recognized as being good
until it breaks and you've got nobody to call.
Right. Well,
So
and
now you got a
it is
system in the cloud. It's free. It breaks, and there's nobody to fix it for you.
Well, and it is. They do sell some support, and I looked at their they have their distribution of OpenStack, and their support is like astronomically cheaper than the Red Hat stuff.
Yes.
And yet people do get the Red Hat stuff because it is, when it's mission critical. You think something like a bank or like a cell phone provider or a payment processor. Like how long could your the credit cards in a city stop working, or the cell phones stop working in a city before it's like bad for the company?
Yeah, and that's why there's no Windows servers out there. Look, I love Windows. It's an incredible operating system. And the reason it's incredible is it managed to work on a whole bunch of hardware and software combinations, which nothing else can do. But because it works on 1,000,001 hardware and software combinations, the drivers are challenging, and that's why Windows isn't very stable or very secure. So other than Active Directory and Microsoft Exchange, for the most part, Windows is a desktop user operating system, and there are no more Windows servers. But I do want to bring in one quick thing. It's pretty critical. It came in from Khalid. Khalid, a cloud architect, can never work as a cloud engineer. If the cloud engineer goes and works if the cloud architect helps the cloud engineering team, they will make such major major mistakes that they will be fired from their job and never hireable again. So Khalid, I say this to the architects, if you imagine looking out at the sky tonight and you look at the moon and the stars and all of it, and then you take a telescope and you zoom into the moon, you can't see the sky. The engineer has to be zoomed in. The architect has to be zoomed out. The second an architect tries to be an engineer, they are a disaster. Plus, the architects don't know the engineering skills. They don't know how to configure things, so they can't do it. So more it's like the other way, Khalid. We cloud architects ask the cloud engineers how to help us do the job because they're the technical people. We're the business executives. So we consult and communicate with the engineers, but we can't do their job. We have no idea how to do their job. It's like a doctor trying to say, hey, I'm a nurse for the day. They don't know how.
Right.
A nurse doesn't know how to be a doctor, and a doctor doesn't know how to be a nurse. They're different careers.
I mean, it's even like, when I was in the previous call with you, and you said something similar. Is that like, I mean, it's like you think of like an architect and an engineer for a house. Is the architect designs the house, and then the engineer is the one who implements it and makes sure that the roof doesn't fall down. You know?
Exactly.
And so, they're different skill sets. They're both very important. But it's like you don't. There's a reason why they're typically split. There are very few people who have the inclination to or capacity to really excel at both. Very few,
because the skill set is so different. I was an engineer. I'm an architect. What do? I do ROI modeling. I buy dinners and drinks. I take people out and entertain them. I give presentations. I write magazine articles. And I lead large groups of engineers. That's what I do as an architect. What's a cloud engineer do? Build everything that I design and help me make sure that what I design is actually going to work. And I'm not just selling PowerPoint slides, because that's what we architects will do. We are business executives. We get a quota. We're great at selling our products and solutions, but that's our world. Architects design things. Engineers build it and also fix it and make sure it works. So, the building architect that calls the structural engineer to make sure the building doesn't collapse.
Yeah.
Same thing here. So it can't go the other way. It has to be this way. So getting back to the Openstack cloud, which is a private cloud, I love that. And I love all the things you're doing. So what kind of clients, what kind of customers use Openstack? Everybody, right?
I mean, it is pretty much everybody. I mean, it's like the reasons to use OpenStack over something like AWS is, I mean, one is there are people who they already have the data center investment, right? And so then that's a way to repurpose these monolithic servers into something a little bit more flexible. It gives you more flexibility. Like you have 100% control over an OpenStack deployment. So if you need something very specific, you would use OpenStack. If you need like very specific, like performance, very high performance, you have total control over that. And I know that that there are specialized services with AWS and whatever where it's like they provide more specific hardware, right, or some GPU or some high throughput network cards, right?
Well, we'll call it high throughput, but it's nothing like the performance we can do in the data center.
Well, right. And so I mean, like, and also those things are of course, like, they're expensive. And so if somebody needs high throughput, flexibility, control over their environment,
higher security,
higher security, or very specific security, right? Yes. It's and I think one of the reasons to not use OpenStack, and this is another way to see what the difference is that if you have a small web application, or you need a couple servers, you don't need to do an enterprise level OpenStack thing. What you would need is data center level electric, which means two electric
power companies, two different what do you call it, transformers. Two different generators, two networks, right. Two different backup generators, and UPSs, so you don't have a power failure. Like, oh, by the way, AWS had a power failure and it took down the whole globe.
Right.
Could you imagine a data center that has a power failure, Nathan? Have you ever seen one?
Right. No.
Other than Amazon, that clearly either gave us some interesting information or doesn't know how to build a data center, or was hacked and didn't want to say it.
Well, and I mean, and I would say that like, I mean, even then once you get past just the building, right? The building and all the cables, then for a production level OpenStack deployment, you need 3 controllers,
Yep.
which just do the control plane, and those need to be relatively beefy. You know, they can't rerun on Raspberry Pis, right? They're real computers. And then you need it, like, you need computes. If you want high availability, you need minimum 2 computes. You probably like, and that's cutting it incredibly close. And at that point, you're like, okay, so and like the error correcting RAM, all those other things, like what is that investment? I mean, it's a ton of money. I don't know. Computers alone, it's going to be what, like 50 grand, you know?
Yeah.
Like,
But you know, that's the thing. People don't get it. If in my OpenStack cloud, which is a data center, if I want to hire Navy SEALs, Israeli commandos, and SAS commandos to physically guard it, being armed, and if I want to have 2 sets of firewalls, I can do it. I can use whatever IDS,
right.
IPS systems I want.
Right.
I can use layer 2 access control lists, which I can't do in the cloud. I can do MAC address authentication. I can do QoS. I have much more capabilities in the data center of the cloud.
Right.
I can get double the performance. I can take one server and put an NVMe RAID array instead of using block storage and keep it a bare metal server. And this thing can have millions of IOPS. Can't do that on the cloud.
Yeah.
So
I mean,
much more control, much more security.
Yeah. Well, and even so, I mean, like, one of the more interesting things with OpenStack is like edge computing, where what they'll do is you have a cluster that has an availability zone that is like, I mean, if you say, like, take like a cell phone provider, they'll have a micro cluster in the antenna building. And that allows so when you're on your cell phone and you're using some app that needs to hit a special service, they can just host that service directly in that antenna building, so that it does so that it doesn't have to make all these hops. And I'm not an expert on the telephony infrastructure, but I do know, like, I have had it explained to me, and it's the path. If you have to go to, like, a central location, hit the tower, you have to go around something like a token ring, possibly a couple rings where you have like 5 milliseconds each hop, you know, and so you end up shaving off like half a second to latency by putting these things in the towers. And you can't do that with AWS because it's going to be in, obviously, Amazon's.
And let's talk about why the need for edge computing exists. If we're in the data center, for the most part, we don't need edge computing. There's no point. The whole point of the edge is this. Here we're in our data center, and it's fast and it performs great. Now we've got 1,500 miles to AWS. Oh, wait, there's latency. So we get a connection between our data center and some other data center that's close, and then we connect that to the cloud. So that's really the reality. The reality is this. All this edge computing is trying to work around the poor performance of the cloud. That's also, I mean, it's an Internet of Things.
And it's also just I mean, physics. I mean, you have the physical distances. And I mean, like, I know, like, GCP has some you know, more or less similar things conceptually, where they'll have they have entry points into their private networks in, say, like, Europe and like these different locations, and you can like shave off milliseconds by going into an entry point that is closer to you rather than bouncing around the globe, because they've shortened the cables. I don't know what they did.
Well, I can explain to you how that works, but I also want to address CEO's trail. Most engineers are hidden from the customer unless they are sales engineers, which are really architects. Sales engineers actually do the architect job. They design, they present, and sell, and never touch the technology. So sales engineers are architects via a different name. So are design engineers, where they design it and don't touch the technology. Now, there are some engineers that are customer facing. They're usually consulting engineers, but very rare. Most companies try and keep their engineers from speaking to the customers, and they try and send their architects to speak to the customer, because the engineers often kill the deals. The architect's talking about business and leadership, and that engineer wants to go in there and talk.
You just said everything that we said. We just had an entire conversation in the chat box.
So the majority of this, I also want to address real quick. Almighty asked the question, which Linux for cloud architects? No Linux certifications for cloud architects, Almighty. If you want to be a cloud engineer, hands-on Linux is good. But if you want to be an architect and you've got a Linux certification, I'm going to recommend you remove it from your resume when you want to apply for architect jobs, because it's too hands-on. You need bigger stuff. So that would be what I would recommend, Almighty.
Yep. And I also took the opportunity while we were having the conversation in the chat box about engineers and the possibility of facing customers in certain roles. Obviously, it's dependent upon how your company is organized and operates. And that's one of the reasons why we included our soft skills in our engineer training, because you never know if you may take that role.
We actually included it for 3 reasons. And I want everybody to understand this. Reason 1, when you go on a job interview, do you know what? 50% of your scores are related to your competency and 50% are related to attitude, communications, and skills. So we teach the leadership skills to architects and engineers because it helps you get hired. 2, soft skills training on average can raise your salary $50,000, $60,000 per year, and empathy training can add another $30,000 per average on year. So we can influence our salary upwards of $100,000 by teaching these skills. Here's the other reason. When I was an engineer and wanted to become an architect, my management said, we don't allow engineers to become architects because you're too techie. So the next day I put on a suit and people asked me tech questions and I pretended not to know anything for 6 months straight. I got a $150,000 raise after that, wore a suit every day, and was then an architect by pretending not to know. So we have to, and basically I also spent about $250,000 on business acumen skills and leadership skills and emotional intelligence. So we give that to all of our engineers and architects, so that if you want to leave engineering, go to architecture, you can. If you want to go to engineering into management, you can. If you want to go from engineering to a CEO or CTO position or CIO, you can. So we give everybody our special blend of leadership for those reasons. Salary, hireability, and career flexibility. You don't want to be the person that's hidden in the back. Because let me tell you, there's a $100,000 difference between that super genius engineer that's stuck in the back and the one that doesn't know as much, that's got better social skills. So we want you to have everything to get all the skills. I don't want you at the bottom. I want you to be wherever you want to be. You like being hands-on tech? Great. I love that. You want hands-on tech and you want to get paid more? Great. You want hands-on tech and one day you want to do pre-sales? Great. I want to make sure you have the tools to do all the jobs, not just one.
So I just want to point out that Elonzo and I are thoroughly enjoying being window dressing. It's amazing. It's like we're not having to do anything except just sit back, enjoy, and be part of the conversation over here in the chat box.
Oh, so the person asked a very legitimate question. What do you do as a cloud engineer on Linux? Everything. Every server you work with is going to be Linux. If you're building a cloud, it's going to be Linux. If you're writing a script, like a bash shell script, it's going to be Linux. Chances are the Python scripts you're going to run are going to be on Linux. You're going to run Terraform, it's going to be on Linux. Everything you do is going to be on Linux. Linux is everything. There's no other operating system in today's world. I mean, there's 12% of the desktop is Mac. Windows owns the desktop. And why? Because it enables people to play video games. I don't know why I don't play games, but people like video games. It enables people to run business applications, which I care a lot about. So, there's that. So kind of keep that in the back of your mind. Everything is Linux. Of the world's 500 top servers, 2 run Windows. The other 498 run Linux. And by meaning and all the supercomputers in today's world run Linux. So there really is no option to run Windows. You've got to become Linux if you're a cloud engineer, Linux for a cloud architect. Everything we design is going to be on Linux. Except for the desktop, except for Active Directory, which everybody uses, and Microsoft Exchange, which pretty much everybody uses for mail and calendaring. I haven't used a Windows server in the last 15 years. Have you seen any, Nathan?
I mean, they do exist, but
Not many.
I mean, I'm like
he says with a slight eye roll as he says it.
I mean, well, I mean, like I was working at Red Hat, so it's not like they if people had Windows servers, they didn't tell me, you know. So like so I do know that. Yeah. So I mean, people had LDAP servers and
Yeah,
stuff like
Active
that.
Directory, yeah, all that
Like
stuff.
you said, right? But yeah, I mean, like
In fact, I
like
run into more mainframes than I do Windows servers as an architect.
right. Well, and I mean, if you're building an appliance, like if you like if you want to do like a virtual network function, or so it's like a VM that is a switch or a router. I mean, you're not going to put that on Windows. It's going to be Linux, or maybe BSD. Which, if you learn Linux, that you're reasonably close, right?
Yeah.
Certainly closer than Windows.
Oh, I miss BSD. That was such a great operating system.
Yeah.
The Juniper routers used to run BSD. I loved it.
Yeah. But I mean, I don't know. I mean, it is mostly like if if you build a website, I mean, like it's gonna be it's gonna be Linux, and containers running on Kubernetes. So it's Linux again. Is a whole there is a lot of Linux, and I would say that even if I mean like if you're in it seems like the place that you would run into Windows would be if you're in like a corporate office where you're managing where it's like people have a lot of Windows desktops where people are dependent on Windows. You'll have Windows infrastructure in that building, but it's like in terms of like it's cloud, there's no real upside to Windows unless you for the cloud, unless you need a specific thing that you cannot get somewhere else.
And I'll take over on this for a little reason, and I'll explain. Plus, it's going to help with the question in there. Small businesses use Windows. Big businesses do not. And I mean, all businesses use it for Active Directory and Exchange and that kind of thing. But small businesses use Windows because it's simple. I don't need a $150,000 Linux engineer. I can hire a $40,000 Microsoft engineer to click a few buttons with the graphical user interface. Now that graphical user interface takes up resources and is much harder to do things than the command line, and a pain. But because it's so easy to use, I can hire a Microsoft person, which is very cheap compared to a Linux person. So a small business might actually have some Windows servers, but our real business won't have any. I mean, they'll have Active Directory and Exchange, and pretty much everything else is going to be Linux. Unless they have an application that's dependent upon a Windows workload. Maybe they had somebody that, made some .NET application 20 years ago and they haven't gotten off of it. So there'll still be some of that.
Yeah.
But it's mostly that. But we try to avoid anything with the graphical user interface. The more services we have, the more services we can hack. So if you guys do like a netstat on your computer and you see that it's listening on 10,000 ports, every port that it's open to is a port you can be hacked on. So with a Linux system, you can basically take your kernel and you can shut down everything that you want. It becomes much more secure.
Yeah, and there was a question about the Windows subsystem for Linux. It does work. So I work with some people who use Windows and use Windows subsystem for Linux for stuff, and I mean it works, but it's a little bit more finicky. There's some issues. I mean, I'm fair. Like, there's some stuff with the native Windows file system where it's where you have to be operating inside this like a little VM. But if you're on Windows, you can run a Linux VM.
Yeah.
Locally, Linux is pretty lightweight. So especially if you do like a server with no graphics running, you can run a little VM and do whatever you need to. You can use containers to run a lot of things that you need to run. So I mean, you can still make it pretty far with Windows and work around whatever the shortcomings of WSL are.
And that's a good point, because what it is an Ubuntu kernel that's added to Windows. So now you've got an operating system with 2 kernels and 2 sets of memory management. And, it works, but why bother? Just use a Linux system and have a cleaner file system, a better file system, and better in every way. But, good point. So, that's a really good point, because, as it comes to containers, and here's the reason Windows probably added the subsystem for Linux. A Linux container can run on a Linux server. A Windows container can run on a Windows server. So that meant that if you had a container that was meant on Linux, it wouldn't run on Windows, because containers need to take the underlying parts of the operating system, some operating system libraries. So Windows systems didn't do any Linux containers. So here, smack a Linux kernel on it, and now we can do Linux containers on a Windows system. A Windows system can't do Linux containers, by the way. I mean, a Linux system can't do Windows containers.
Right. Right. It needs the system kernel, a compatible kernel.
Yeah. And containers are typically orchestrated with either Kubernetes or Openshift, which is just Kubernetes. So what's Openshift?
Openshift is a container orchestration platform. So it's for microservices. Typically, kind of the difference between a VM and a container is a VM. A VM is running its own.
I can take that, and I'll have you toast it. So the difference between a virtual machine and container is this: we take a server, we add a hypervisor. Each virtual machine gets their own operating system, applications, and dependency libraries. By comparison, a container is basically where we take an operating system and we logically virtualize it, so that we've got one container that's logically isolated from another container. So what happens with a container, and then I'll go back to you with Openshift, is the container takes the operating system and the libraries of the operating system and just have the applications, and it's very lightweight. So that's the main difference between a container and a virtual machine. We use both as cloud architects, but here's the thing. OpenShift is like Kubernetes, and I wanted Nathan to talk about it because Kubernetes is much more of an engineering topic.
Yeah. And so yes, so I mean, like Mike said, I mean, the VM is essentially it literally creates a virtual computer that then you install the operating system on, and so the VM has its own kernel. The container is essentially just uses inherent features of Linux, like C groups and chroot jails and different things like that, namespaces to contain the application and any specific libraries that it needs for that application, and then it relies on the underlying system. And so Kubernetes is, I mean, similar to the architecture that I described with OpenStack. It'll have essentially production Kubernetes system will have three controllers. They're called master nodes usually, and then you have any number of worker nodes. The worker nodes are what provide the compute power. And so the kind of the difference, the shift with OpenShift or with Kubernetes is that it's much closer to like infrastructure as code. It's really inherent in the system that it's infrastructure as code. It also, rather than with like a virtual machine, you're installing an operating system, so there's a lot of things inside the virtual machine. Usually a container is way more lightweight, and so with something like Kubernetes, what you can do is you can say, oh, I'm going to deploy this, like I need a web server, and so your web server needs the database. It needs these front end containers, and so for your typical workload, on your off hours, you only need like 3 of those front end containers being served by a load balancer. The load balancer will split the traffic between the front end containers. If you get a huge spike, Kubernetes will automatically scale to what you need it to, so you can set all these quotas. And so it's really like it's like it's microservices orchestration using containers. That was a lot of words, but that's
but you know,
they're all true.
The interesting thing about that, and some things will always be server-based and virtual machine-based because containers don't do things all as well as servers, and some things will be containers. But here's the reason they're efficient. You have to install the Linux operating system. You're already dealing with 2 gigs of DRAM that you just lost. Some of these containers only need 1 gig of DRAM, not enough to even run the operating system because they're so lightweight.
Yeah.
So I love all this Linux stuff. If I'm not careful, people are going to realize I'm actually a techie, and they're not going to see me as a CEO. So I have to be a little bit careful here because other business executives reach out to me on a daily basis.
So let me jump in here.
Thank you.
It's weird to jump in and steer the ship after an hour of not steering. I'm used to having to do it like every 5 minutes with Mike and Elonzo. They just go down rabbit holes. But this time I decided to let you go down the rabbit holes and not steer you. I don't know where you guys want to go with this conversation, but I think it might be good to talk about Nathan and Mike and Elonzo and our cloud engineering program and Linux for cloud computing and how it all fits into what we're trying to do here at Go Cloud Careers. If you want to, if you don't want to, y'all can talk about whatever you want. I'm sitting here enjoying the conversation.
Chris, I like that. And my beautiful baby girl, Cindy, is coming in here and she's telling me she wants to be taken outside. Cindy, can I borrow you real quick for the audience? You're so special. So this is my beautiful cat, Cindy. She doesn't like to be picked up, but she's lovely, wonderful, and the sweetest little girl in the entire world. Sorry about that. But anyway, she came to visit me. So after we get past my beautiful cat, Cindy, who's the second love of my life after my wife, let's go talk about what we're trying to do. So me and Elonzo and Chris and Nathan and Chow and Leo, what we are trying to do is get everybody that wants a job hired. Cloud architect, cloud engineer. And in order to do that, we know certification is not going to do it. Certification gives it the name of a service and how to configure that. And if you're looking for a junior level, entry level admin job or a help desk job, certification is going to get you there. But if you want anything better than help desk, certifications aren't going to do it. You need to know. So what goes into it? What goes into a cloud? Well, it's networking. What kind of networking? BGP, OSPF, that kind of stuff. IP addressing, subnetting, supernetting, all that kind of stuff. And we teach all that for both architects and engineers because you need to know. NAT, one-to-one NAT, one-to-many NAT, static NAT, dynamic NAT, all that stuff. QoS, you should know QoS and how it works. You should know WAN protocols such as private lines, IPsec tunneling, SSL-based VPNs, software-defined networking, Ethernet over MPLS, and we're trying to give the strategy of this. So, what else goes into it? It knows Linux. Why? Because 90% of Linux servers are Linux. So if you want to design systems on the cloud, either as an architect or an engineer, we architects need to understand the Linux kernel and how it works. The engineers need to know how to build it. So we have to do that. So once we get past these things, what about Terraform? Architects don't touch engineering, don't touch Terraform. We don't build anything. We don't touch it. But cloud engineers sure do. We've got Nathan teaching how to configure the Openstack cloud via Terraform. Openshift, we've got some of that in there. Why? Well, we have to because containers are there. And whether we're on AWS, Openstack, we're all going to be using Kubernetes. And guess what? It's the same silly Kubernetes. So what we're teaching you how to do it is, and then we're going to teach you 3 different clouds. Why 3 different clouds? Because nobody's crazy enough to use a single cloud. 87% of customers are now multi-cloud or hybrid cloud, and 97% claim to be multi-cloud or hybrid cloud by the end of the year. So only 3% of people are stupid enough or crazy enough to put all their eggs in one basket and hope it doesn't fall apart, which means 97% of people are smart enough not to do that. And I hate to say it, it is stupid to put all your eggs in one basket and expect the basket not to get dropped and break all your eggs. So, so we're trying to teach that. What else are we trying to put in here? The leadership skills, the communication skills, the emotional intelligence skills, the empathy skills, the business acumen, the leadership. Doesn't matter what you want to do, no matter what it is, you'll always have career agility. And that way, if Elonzo decides tomorrow, and he's an architect, that he wants to do something different, like work for me, he can, because he's got the skills to do it. And those are the kind of great things that we like to build. We want to make sure that you guys are there. So Linux is critical to our strategy, and hence the reason I'm so excited with Nathan. And why is Linux so critical? Everything that matters is on Linux. Everything. Everything. I'm not joking. Everything that matters is on Linux.
Well, I guess I'll say something every 60 minutes. Um, I'm wondering.
I've been wondering if I should just turn my camera off.
You know, I really want to know. Okay, say for instance, when you were at Red Hat, was this more of a pre-sales role, or did you have to communicate with the engineers so that they can communicate to the clients? What was the daily, day-to-day operations for you?
I was a technical support engineer. So I was on the enhanced support team. They've got a specific name for it, enhanced solution support or something like that. But so we had like customers that had like elevated SLAs, like needed quick responses, and so they had like a special contract. And then they would have, a lot of times they had, so at Red Hat you'll have like and at Redis too, you'll have like a technical account manager for, there's a lot of different roles, right? So you'll have the solution architect will do the kind of planning out, like at Red Hat, what is called the solution architect will kind of, they have a fair amount of technical knowledge, but not specific technical knowledge. They understand the product, they understand what it can do, and they have a good understanding of what the client is looking for, and they can talk to people and work that stuff out. If they have questions, then they go to the either the software engineers or the support engineers. And then you have the technical account manager. So the solutions architect is kind of front end sales. Technical account manager would manages the account and has kind of a similar amount of understanding as a solution architect. A lot of times, like and sometimes there would be like a TAM that would go into it. They'd worked on Openstack before, and then they're like, they decided to do the technical account manager thing. But in my role, I got to, because it was these special contracts, I got to work a lot like closer with the TAM, and so then the TAM, like I got to see a little like firsthand a lot of that like soft touch, good good customer service stuff, and I didn't really have to deal with that much myself. Like he was always there. I could always ping him and he would always respond, right? But essentially, like, I mean, my like I had a small team of like on a given shift, maybe 5 people as part of a larger, maybe 10, 15 people in kind of OpenStack, and we would like we'd get tickets and we'd work them, and so we'd have on the other side some cloud engineer. At a certain point, there was one of the companies was planning for for their next upgrade, and so they had these, I mean, very 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 senior engineer, like it's a team of people, right? But I was interacting mostly with the engineers, sort of like planning things out and saying, like, we have these goals, we need this to work, and kind of figuring out how they were going to then deploy like their 1,000 OpenStack things, right? But so it was, I mean, for me it was like just daily is technical support. Although it's like I do think that even if you're even if you're like strictly technical, it does make your life a lot easier if you understand people.
Yeah.
And I mean, and even things like, sometimes you're working with somebody and it's like, you're trying stuff and then they get in a bad mood, and then and so then like and then they're mad at you, right?
Yeah.
And so at that point, like I've got a teammate, like I'll have have my teammate work with them because they don't dislike my teammate, right?
Exactly.
So just like I do think it's important. It's very important to understand people, even if you are the troll that they call to like fix the stuff, you know?
Yeah, and you know what? I'll actually cover this because this has been my life.
I got a question after Mike covers this.
I typically called when the engineers and the customer are angry or the engineers are frustrated. So I am not joking. One year, I spent $100,000 buying engineers lunches and dinners, and another $100,000 buying dinners and drink to the customers, just trying to and entertain them, trying to find out what they wanted.
Yeah.
So I'm literally not joking. Half of the job of the architect is to get everybody involved and talk. And it's all about schmoozing and kissing babies and knowing everybody. And that way, when things break down, you knew who to call. So for me, you know, I have a friend, Daryl. When I knew Daryl, he was the first architect I ever met. He knew very little about technology, and he sold more technology than 3 sales reps and a team of sales engineers. Because what did he do? He went in there. He had the best business acumen I'd seen in the team. He was the most likable person. He would go talk to the customer, find out everything they wanted, and then he'd go back and he'd say, hey, you engineer, you engineer, you engineer. You help me make this work. I have no idea. He would sell it to the customer, and they would buy it every time. I think he was responsible for like 30% of the company's income. One person. And he didn't even know how the tech worked at the time. That's how good he was. So yeah, having people that have people skills will separate you from everything. And you know what? And I'll turn it to Chris. I have a really good friend that hires a lot of engineers. And you know what she told me a long time ago? She says, Mike, I need someone that can do the job. And she says, you show me 5,000 people, maybe 1 or 2 people can do the job. And then she says, if I can find those 1 or 2 people that can do the job, find me somebody that I can tolerate. Someone that isn't miserable, that doesn't come to work and complain, that's not going to start fights with the people on my team. Find me someone that can do the job and someone that I can tolerate. It's that hard.
I do think that you know, like before I'm also a musician, and so there's this idea that, you know, and something that young musicians do a lot is you know, you get on stage and then you're still worried about all these little details, you know, and it's like, and once you're performing, you should not worry about it anymore. You know, you can't worry about it anymore. And so, and I think it's the same thing when you go into an interview, what you do is it's like all of the knowledge, all of these things, you prepare as much as possible. And when you go into the interview, your job is like a musician. You get on stage and you have fun. You go out there, and what you want as a musician is you want people to like you, even if your song is bad. and the same thing when you go into an interview is that people, like, you don't have control over the other people who are being interviewed, and sometimes you will go in and there's going to be a guy that is way more qualified than you, and they're going to hire him, and that's just what it is. What you can do when you go into the interview is do as best as you can, and then be fun, have them like you, get along with them. You know, of course, you want to answer the questions as well as you can. If you don't know a question, don't lie to the guy.
Never.
Because I mean, right, because he's not asking that question because he doesn't know. He's asking the question because he does know. And then you know, and then, you know, if you like, a good interview and a good interviewer, they're going to ask you things you don't know. And so you have to be good at failing in front of people and still being cool and still being likable while you're failing. And if you can be like, there's all of this legwork to do before you get in the interview, and then the number one thing when you go into the interview is be likable even while you're failing. You know,
absolutely. I got hired on my first tech job 25 years ago. I was practicing internal medicine before this. I interviewed with a guy named Devendra. He asked me a personal question, I answered. He asked me a tech question, I answered. He asked me another technical question, and I answered. He gets to something I don't know, and instead of lying like everybody else, I said, Devendra, I'm sorry, I've not had the opportunity to learn the technology yet, but I'm highly energetic, highly motivated, and I absolutely love technology. And if I was in your team, I'd stay up and read 1,000 pages a day until I mastered it. But I just want to get to know, I know what I know and I know what I don't know, and I want you to know me best. Right there, he shook out his hand. And I was interviewing for a network engineer job. And you know what job I got? A senior network engineer. He liked my people skills and my emotional intelligence so much. that it was that. You know what? 6 months later, I was the lead architect, and that was at the world's largest ISP.
Wow.
And your honesty.
And my honesty. It was the honesty.
Right.
Devendra, I don't know this.
Well,
But
then that is the other thing. Like I have a friend who's just has just gotten his first kind of entry level tech job, and he, I mean, the thing that I told him is that, you know, like especially like, and if you're going at entry level, there's going to be people who need to trust you.
Yeah.
They're going to tell you what to do, and if they don't know, like, if you won't tell them when you don't know something, you like, and at any company that is doing anything important, you're going to cost the company a ton of money.
Yeah.
By saying you can do something and having it not be true. It is far better to have somebody who doesn't know something and tells you, because then they can learn it, and you don't delete everything.
Yeah, that's when people say, "Hey, Mike, can I get an internship as an architect? Will people be hiring me free?" I said, "No, because you're going to go in there, you're going to design something, you're going to cause $1 billion of damage, and yeah, it was great that you didn't charge them $150,000 a year. You only cost them $1 billion. You saved them 150. So no, and that's the key, is the ability to damage things in tech if we don't know what we're doing is so great, and that's why nobody cares about certifications, because the certification that teaches you the name of the service and how to configure that service doesn't help you troubleshoot an OpenStack cloud when it's not working.
And that's why you start building your own cloud right here, so you don't make that multi-million-dollar mistake.
Yeah, and that's why we give everybody access to our data center. We've got 100 plus labs in our engineering program, and everybody builds a cloud twice, actually.
And this leads me to my question.
Yes.
All right. So everyone knows I'm not a tech guy. I'm the operations guy. I'm the business guy. So by this point, I know what Openstack is.
Yeah, he does.
Just because of the nature of having worked
Exposure.
for this company. I know it, osmosis. It finally sunk in, you know, even though I was trying to ignore it. I know what Openstack is. But we've got some people on the YouTube, they might not know what the name Openstack means. I know we talked about it earlier, but we kind of wrapped it up in an entirely bigger conversation. So what, on the simplest of terms, what is Openstack, and how does it relate to what we're talking about on the simplest of terms for a non-technical person like me?
Did you hear Nathan take that deep breath?
Yeah, I'll do this because I'll do this because I'm used to taking complex things and simplifying them. OpenStack is just a private cloud software. It's the software that enables you to take the data center and turn your data center into a cloud, just like Nutanix. So what happens with all clouds, AWS, Google, Azure, Dell's cloud, Palo Alto's cloud, Verizon's cloud, American Express's cloud, all clouds, it's just a data center. So you've got all these servers doing compute, and you've got these storage area networks, block storage, object storage, file storage. You've got routers and switches that send the data around. And you've got firewalls, and you've got these physical load balancers from F5 that are load balancing in between servers. So we install some cloud software on it, and all of a sudden we have a cloud. So now we get a management console just like AWS, and we can click on the management console and make a virtual machine, and the cloud will say virtual machine goes on server 65237. Container goes on server 62368. And the cloud will just determine where your stuff goes. So everything that AWS does, auto scaling, an OpenStack cloud does. Anything that you can think of, software load balancers, logical devices, virtual machines, containers. An OpenStack cloud enables you to take your data center and turn it into a cloud that's equally powerful, if not more than AWS's or Azure's. But because the data center is under your control, you can get higher performance, higher security, and much more control. What is the public cloud? Average, ordinary stuff for average, ordinary businesses. Pre-made for you. What is OpenStack? I am a bank, and I want to build the perfect bank for the perfect cloud for my business, with maximum security, maximum performance, maximum tuning, and minimum latency. So most companies in today's world actually are installing a cloud. Now, whether that cloud is OpenStack, and I love OpenStack because it's the Red Hat one and it's super solid, but it's hard to use. You have to be smart to use OpenStack. You literally have to be a very
there's that subtle dig. It's like, yeah, you got to be smart. You can't.
You actually have to know what you're doing for this. So it's kind of like setting up a Linux servers. You have to understand Linux. How do you set up a web server with Microsoft? You click 4 buttons in IIS and it's running. You can't do that with the Linux cloud. That's why small businesses use Microsoft stuff, because it's easy. Big businesses will pay for the heavy salaries to have the people that can give the best technology. So kind of keep that in the back of your mind. OpenStack is just a private cloud. And guess what? If today, me, Chris, Nathan, and Elonzo all bought 10,000 servers or 100,000 servers, a bunch of routers and switches from Cisco, and a bunch of storage, and we decided to call it the Go Cloud Crowd and charge money for it, we could do it because it's just another cloud. Hey, by the way, you guys want to buy a bunch of used servers? We should start our own cloud.
So that leads me to a follow-up that I saw in the chat box. Someone asked, why I don't remember exactly what they asked, but they asked, why would I need to learn Linux for cloud engineering?
Okay, so it's a great question. If you're a cloud engineer, what are you going to be doing your whole life? You are going to be building. You're going to be setting up virtual machines. They're on Linux. Containers, they're also going to be on Linux virtual machines. Container orchestration, that's also Linux. DNS, if you're not using a managed service, that's also going to be on Linux. Any of your addressing stuff is going to be on Linux. Some of your virtual networking things will be on Linux. The rest will be routers. So there is nothing in the cloud that doesn't operate on Linux. So if you want to be a cloud engineer and all you know how is to configure things, you're not an engineer. An engineer knows how to build the server, what kind of server power is needed, what kind of server can host what kind of database, how can the server scale, what kind of latency is needed. And if you don't know Linux, you won't be able to set up anything. And remember, architects don't touch the tech. Engineers touch the tech. And what tech is the cloud engineer going to touch all day? Linux, Linux, and more Linux. So if you don't know Linux, you can't work on the cloud. Now, you could be a cloud admin.
Right. I would say you're right. Is if you don't know Linux, you're going to be the guy that reads the document and then copies the commands. So they have like a mop, a procedure.
Yeah.
And then they're going to be like, hey, we want you to do this, and you're going to copy and then paste it into the terminal, and copy it and then paste it into the terminal.
So what I know how to do. Okay.
Yeah, yes.
Right. But here's the thing.
I know how to Google and copy and paste code.
So, yeah, but here's really the thing we need to think about. So, is anybody going to hire Chris as a cloud engineer if he has to Google it every time he has to do something?
Right.
I hope
And
not.
more importantly, I need, an engineer knows stuff. An admin is basically config something. So if all your job was to be is just to configure something by clicking 4 boxes, and that's about a $10 an hour job to a $20 an hour job, then you don't need Linux. But you won't be a cloud engineer either. You'll be a cloud admin. And the cloud admin job will be outsourced overseas to the cheapest bidder because it doesn't matter where you're at. But if you want to be a cloud engineer, you need knowledge. You need to know what systems interact with what systems. What impact does this firewall have on something down the line? We've got a user that's passing the firewall, which sets off the IDS IPS system. Why is it setting off the IDS IPS system? If you don't understand the heuristics, you're not going to be able to understand it. Now let's talk about the storage in there. How do we deal with the poor performance of cloud storage? The fastest AWS EBS volume is pathetic. They'll tell you it's great, but it's pathetic. Go to the store, go buy a Samsung 980 Pro for $100 and they'll give you 1 million IOPS. Now go to the cloud, buy something that's going to cost you $4,000 a month and you'll get 250,000 IOPS. So, those are the things that we have to work around in the cloud. And if you don't know how the cloud works or how the storage works or how the networking works, you can't build anything. Because what's going to happen is you're going to click one button and it's going to reverberate through the entire system and take down 50 servers. And you won't know how to fix them.
Yeah.
So that's why it's important to know Linux.
So I can't Google.
It's like a mechanic that doesn't know how to use a tool.
And that's why you gotta be smart to learn to work on OpenStack.
Yes, because you need to know so much about Linux. It's not Mike's hobbyist knowledge who's played with Linux for 20 years. I'm not good enough.
Yeah, trust me. When Cindy breaks stuff, Mike usually calls somebody. He's like, Cindy broke this.
Yeah, and I have the best troubleshooting coach in the entire world. I've got a beautiful cat. She likes to unplug servers, use her paws to plug in servers. Oh, she does all kinds of things. Types on the keyboard. Oh, she's all kinds of creative at helping troubleshooting.
Oh. Yeah. Anyway, that's my contribution to this discussion. That's way above my head.
Did I admit to actually knowing tech tonight? I hope I didn't do that because I've been.
No, we let Nathan take the brunt of the tech.
Thank God. Thank
That's
God. Okay, because
a little
all I
bit.
wanted to do was translate really smart engineer to things that are simple to understand. Because that's basically my career as an architect.
Mike, do you think we could ask Nathan what would be a great resource for those who want to stick their toe in the deep end of the pool for Linux?
Yeah, ask Nathan.
Nathan, let her rip, man.
Well, they should take that Linux course is what they should do.
Okay.
Actually, yeah. So
Yeah.
put that on the website.
Yeah.
We haven't publicized it yet, but we have an inexpensive Linux course for the people that are not in the cloud engineering course, where you will become a master of Linux.
Throwing me a curveball here. I'll get it figured out though.
We'll figure out how to get that course launched, and it's at a price that anybody anywhere in the world can afford, and it will give them really good skills.
All right. Well, surprise, surprise. Guess who already had it ready? I just got to click the launch button.
Okay.
Anyway,
So,
I'll let you talk.
so as it turns out, via a surprise that I had no idea, we have a Linux program for you right now.
And we'll let Nathan talk about it.
I mean, so yeah, like Mike kept harassing me to make a course, and I couldn't while I was working at Red Hat, just because of conflict of interest reasons. And I got recruited by Redis. So now I'm free. I became free to do this. I put this course together. One of my goals with this course was to at Red Hat I learned from a guy, like the guy that trained me. There were two people, but one in particular, just his style of training really taught me how to train people, I think. And one of the things that I wanted to do is give give the experience of being trained by someone who you're working with. Is like where you're just there's some written material, there's exercises, but the videos are me at a terminal going through stuff, talking about Linux. And what I do is I start from setting up a VM, so that you can have a test bed, and then we talk about command line basics. I don't have it in front of me right now. Command line basics. Talk about kind of more or less how Linux works. There's so much there that it's like, and I'm trying to cover a lot of ground, but it's like give you a pretty good fundamental of the Linux file system, how to get around Linux, how to find information in Linux, how to install stuff. There's some bash scripting. There's a lot of stuff. There's some OpenStack stuff. There's some Terraform stuff. What else is there's networking, some troubleshooting stuff.
I'm going to define it the way I would.
Yeah.
This course is enough for someone to get a job as a Linux engineer completely, from this single course. It's not the full course right now where we have it with all the communication skills, but you know what? If we did, it would be enough to basically get your job specifically in Linux. So you know what?
Yeah, and I mean, and I think that it's like another thing that I tried to do was communicate. There's a lot of information that is in the videos, but since there's so much to know about Linux, I tried to kind of get people working the way you would work if you were at Red Hat. There are certain things that I show you and I say, hey, go look at this, investigate this, find out about this here, look at this. So there's in addition to the videos and the written material and the exercises, there's kind of tasks that if you're engaged in the program and interested in the program, you'll get out. The more you put in, the more you'll get out.
And when I went through every one of those videos, and I sure did, there's two kinds of Linux training. There's the usual, you follow coursework. Yep. Do this command, this command, this command. And guess what? You passed the certification exam and you don't know anything. And then there's this. What Nathan actually did, he didn't tell me he did this, but I watched every video. He took it from someone, this is what I assume you did. you basically made it like, I've worked at Red Hat. I've seen all the problems people have made, and I'm going to teach you how to do it the right way. That's what I saw in your videos, from the perspective of an expert at Red Hat as opposed to just Linux training.
Yeah. Yeah. And I mean, and the thing is that, you know, like you take this course and, I mean, I've been doing this, full time for 4 years, as a hobbyist for a long time. And I worked on computers, but even before that, it's like, I mean, I think this is a very good foundation and a good skeleton to build Linux expertise if that's what you want to do. It's enough for you to say I know Linux, you know, and you should, as you go through the course, you should you know, use Linux, play with Linux, set things up in Linux, you know, as much as possible. If you really want to know Linux, you do have to put in the hours. But I think that like my goal with this course was to really provide something unique and special. The way that I'm talking about products here, I'm talking about Linux as I'm typing at the terminal, going through stuff, talking about how things work, talking about people's relationship to it. I mean, I try to convey, you know, as much deep knowledge about it as I can, packed into something like 9 hours of video, 10 hours of video. It was exhausting.
I don't remember how many it is, but
he schools the rock. Let it dry.
Like a lot. It feels like a lot, which
it was a lot.
It was a lot because it was deep tech. It wasn't like Udemy. This was the real deal.
I mean, and you know, the Linux stuff goes and it starts off, you're like, let's change directories, and then by the end of it, the OpenStack stuff, I let myself go down the rabbit hole with the OpenStack stuff, and it is, you know, and again, OpenStack is such a huge product, that it's, you know, and it's taken me, took me 3 years to get to the level of knowledge that I'm at with OpenStack. But it's like I really tried to present, you know, like bust it open and show you as much as possible in a way that other resources aren't going to show you. The internet, like, you know, and I tried to design in such a way that it sort of plugs into your research that you can do on your own easily, so that you get this specialist information, and you can build that knowledge, read documentation, set things up, do the exercises, and I think it's an, like, what I believe and what I hope is that it's a fantastic foundation for a Linux career.
Well, I watched every one of those videos, and I actually did those labs, and I'm accidentally convincing people that I'm a techie. I was blown away.
Cover's blown, Mike.
I watched the videos, but I didn't do any of the work. But from my perspective, as someone that's grown up in education, both of my parents are college professors, and I'm really big on the presentation of education and training. What struck me was the way that Nathan presented this, but as well as, again, I'm not a technical guy, but it's fairly evident from what I saw in those videos that this is a deep well of information that's out there. And you encourage people to look deeper for more information and more specialties and more just to keep digging if they're interested in that. And that's something that I really liked, because obviously we can't cover every single thing. It's just like I'm familiar with Python. It's like if I tried to teach somebody every single thing about Python, I mean, like, no, it's like I would be teaching you things that you would never ever touch in your life, because you're not gonna. There's no reason for you to use it. So I'm assuming that there's a similar case here. But
Chris, I have no idea.
I did put the link for the program in the chat box.
I had no idea we were going to launch that program today. So
Neither
wonderful.
did I. Neither did I.
But I want to make one caveat about the Linux program. If you are in our cloud engineering program, it is already included. So don't buy it a second time.
Don't buy it.
So if you are in our cloud engineering program, it is included. If you are not in our cloud engineering program and want either a job as a Linux engineer or a Linux admin, or want to be better prepared for a cloud computing career, then this is an amazing course for you. It's just that for the students in my engineering program, they already have it, and I never want anybody buying anything that they don't need or anything that's extraneous. How often do students call me, Chris, and say, I want to buy this, and you say, no, don't buy it, it's not right for you?
Yeah.
Every day? How many times a day do I tell people?
It's at least every day at this point that I'm having a conversation with somebody that's asking about adding this, and I'm like, well, what do you want to do? What is it that you want to do? I don't want to. I could sell you every single product we have in our portfolio, but there was a gentleman who I was speaking with the other day that while we were having our conversation, we weren't speaking on the phone, we were speaking on the computer. While we were having our conversation, he bought a second program while we're having a conversation about which one he should do. And he ultimately decided, okay, I only need to do the one. I'm like, yes, let's focus on what you need to do. So we refunded his second purchase, because there's no reason for people to buy this and that and this and that. That's not our platform. That's somebody else's platform.
That's everybody else's platform. Is let me sell you all the stuff you don't need. My architect students, I've got almost 1,000 of them, and they say, Mike, should I take your engineering course? And I say, no, because that'll make you an engineer and you want to be an architect.
Yeah. Now, I will give a caveat. It's about what you desire.
Yes. If you want to be an engineer, be an engineer.
If you realize we have a window, we have a small window where if you enroll in one program and then you realize, this is not what I desire to do, come to us. Speak to me, Mike, Elonzo, Nathan, Leo, Chow. Speak to somebody. Say, if within the first week or so you realize it's not what you want to do, that okay, I want to be an architect. I don't want to be an engineer. Send a message to somebody. Yeah. We'll get you where you need to be. We just don't want you to do everything.
Yeah, we just don't want you to buy stuff that you don't need. Buy the one thing that's going to get you hired. And is there an adjunct? Maybe, but don't just buy things from different careers, because you know what? If a cloud architect starts studying sysops and DevOps and goes in a job interview, they're not getting hired. Why? Because we don't want a DevOps engineer or a maintenance person. We want an architect. So it's about having the right skills for the actual job.
So we've got a couple of questions that popped them in the chat box.
Good. Let's start asking them. So
I'm going to take the first one, just from a purely operational standpoint, and then I'll let somebody else take it from another standpoint. Is Linux included in the Cloud Architect program? No. Because as a cloud architect, you do not need to have deep knowledge of Linux. But if you want to enroll in it, you can. If you want to enroll in it so that you personally have more knowledge, that's on you. Yeah. But I am not going to encourage you to enroll in our Linux program.
Exactly.
If you desire to be an architect.
Yeah. And I think for somebody who doesn't work with it directly, you can install Linux, you can play around with Linux, get kind of an understanding of some of the tools. You can launch stuff in the cloud and put little test applications together. Mm-hmm. And if you're not working directly with Linux, just doing enough to understand it. I use Linux as my primary operating system anyway, and so that's like, I would just it is possible to just use it if that's something you want to do.
What you're saying is exactly what we do. We have labs in our architect program, and we encourage people to do it if they're interested.
Yeah,
but we're not. We're not encouraging them to go out and spend a couple of $100.
Yes, exactly. Right.
So,
and those cloud architects, they set up the LAMP stack, they set up Samba shares, NFS shares, they build web servers, they build OpenSSH VPN concentrators, they build IP tables or UFW firewalls, which is all Linux. Then they build a Linux cloud in our architect program, so everybody learns Linux, but the level of knowledge that you need to be a cloud engineer in Linux is sky high versus the architect, We could almost do architects training by basically saying, take your daily notebook, switch it over from Windows to Linux and deal with it for 3 months. And then at the end of that, you've got the Linux knowledge for the architect, not the engineer, but for the architect, that's enough.
Yeah, I don't want to degrade our architect thing, but we were talking about copying and pasting earlier. Yeah, that might, that might be kind of what I would do.
But let's focus on the architect thing.
Yeah.
The architect has to design and present and sell $1 billion thing. So think about the level of business acumen you need, understanding of all the things and how they work. Because when you design it, you have to know how they work. So it's just a different knowledge. We focus on design. They focus on building. Equally deep, just different. Harjinder, how much do we need to know about Linux as a cloud architect? Where do we stop? And when do we learning about this tool has gone too far? So Harjinder, strong knowledge of Linux for the most part in every career is valuable. I almost feel like everybody should know Linux. Now, having said all of that, for the architect, if you're not used to being an architect and you've not designed and presented and sold $100 million solutions before, I don't want you focusing too much on Linux.
Yeah.
I want you focusing on architecture, your design skills, your business acumen, your CXO relevancy, your ability to do an ROI model, your executive presence, because those are the skills that get you hired as an architect. And let's be fair, as an architect, if you're a Red Hat Linux certified architect, it's not going to raise your salary by a penny. But these skills, the soft skills, communication skills, executive presence, can add $100,000 to your career. So for the architect, where should you do it? Understand the Linux kernel. Understand, where the kernel is, where the drivers are. Understand the Linux hypervisors like KVM and QEMU. And for the most part, that's all we need to know. The engineers, though, they need to be Linux strong people.
Yeah.
It's all about training for your job versus somebody else's. That's why a football player and a marathon runner train differently. Different sport.
Yeah.
Yeah.
There also there some two other more technical questions. I had a question earlier. How often do you use Netcat? I use it.
I was trying to go back to find some of these.
Yeah. And I use it some. I mean, it's a very specific tool. It is actually in the Linux engineering course. I show some stuff with Netcat. It's good for testing ports. Depending on the port, you might just use Telnet. I mean, you can use Netcat on 2 different systems to transfer data. I mean, it is a cool little application. It's very, it's very rudimentary. So it does, it has its uses, but it's not daily, and what's the other one? Please share some tips for learning Bash scripting.
Yeah.
The answer to that question depends a little bit on if you do other coding or do other scripting. I'm not really a coder, but what I would say, like if you're starting from nothing with Bash scripting, what you really want to do is you want to go to some guides. There's a Learn X in Y Minutes is a website that just is a reference for how things work, how the different languages work. So you can go look at Bash and it will explain these different things. What you want to do. The way I learned Bash scripting is by having problems that scripting could fix and then writing little scripts. And so it's even just like I have a VPN connection for work, and so what I did is I wrote, it's 2 different scripts. What it does is my issue with the VPN.
Do we have this in the program that you created?
There's Bash scripting.
Okay.
But so what I mean, the simple answer before I talk about my little VPN script is you want to learn things like if then statements. You want to learn case. You want to learn there's the how to do conditionals like the test thing or the square brackets, which is part of the if statements. But if you learn if, for, which is just a for loop, and like those 2, if and for, will handle most of the logic that you need in Bash. and then you want to learn things about like special variables, and you can and how variables work. But start writing scripts that solve problems, and then get bigger problems and try to write better scripts. And so every time you write a script, don't just do the simplest thing. Try to figure out a really good way to do it. And that's one thing that's made me better at bash scripting. Is I like when I was first starting, I'd write like lazy scripts, and I'd be like, okay, this if I run this script and don't pass the right stuff, it has like error output. So what I do is I do some error control in the script, so that then if I don't use it right, it gives me a usage message, right? And so it's like kind of make your scripts a little bit smarter, a little bit better each time, and just like the point of scripting is to make your life easier. And so, find things that bother you and fix them.
Yeah.
Chris, why don't you go to VNHGs? Linux is your primary, because VNHG figured out my secret. The whole reason I give people Linux therapy and do half of the projects that I do like this is if I say use Linux as your primary desktop, you're going to be forced to get used to that command line, and you're going to have to work around so many things to be able to use it, and that's how you're going to learn it. So VNHG, congratulations, you figured out my strategy. That's the reason I use that. That's the method. So in fact, Nathan, if you want to talk about a little bit about learning hands-on with what I'm going to do, and it's going to take me 30 seconds, is I have to take the cat to the door because she's literally crying that she wants to go out. So I'll be back, everybody, in 30 seconds.
Oh, and I've got more questions for us to use too, ready to go. So I'll let you talk about that, Nathan.
Yeah, I mean, I don't know. Like, I think Linux has gotten a lot better for the desktop than it used to. And you definitely there are pitfalls. You run into certain things like issues with video conferencing, which I don't really have right now, although my camera's not very good. But I don't know. Like at this point in my life, I've done it long enough that like if I use Windows, it is like I want to go do something, and it's all the buttons are in the wrong spot. And I'm very comfortable with the command line. I mean, the thing that I liked about Linux early on is that if something didn't work, it's not some guy's fault, and you can never fix it. It's like it's a lot, like half the time at least it's my fault. And if you go, well, the software doesn't do that, you go and you can see like people arguing about with the guy who wrote the software, and he's like, I'm not going to do it. If you want to do it, write it. And so then nobody writes it, and so then it's like then I get to choose not to write the fix that I want, rather than just being stuck forever.
Right.
So I mean, yeah, it's I don't know. You get used to it, and it's a different set of problems than you would have on Windows or Mac. But I mean, for me, it's preferable at this point.
So I've got. I think we might have covered this question earlier. I think we had a conversation about this, but I just want to make sure. What distro should I use to learn Linux?
And actually, that's a really good one. I'm going to give a little guidance here to Al, since I know Al. Al, in business, they typically use SUSE, Red Hat, or Ubuntu, or some flavor of those. Are there any other major business distributions, Nathan?
Not really. I mean, like in the course in the Linux engineering course, we use Ubuntu. There's a couple reasons why we use Ubuntu. I mean, Ubuntu is if you're learning Linux, because Ubuntu is the most used in the cloud. It's the first downloaded Linux for most people. There's way more resources. I really like Red Hat Linux, but a few things about it and a few things that make it kind of a bit of a harder on ramp. The only thing that you're missing going with Ubuntu is SE Linux. There's an SE Linux module in the course, and and then the package management's a little bit different. There are a couple things that are a little different, but if you do Ubuntu, do CentOS, which now CentOS is being replaced by Rocky Linux. You can use Rocky Linux. It's free. It's it's the same as Red Hat pretty much. But I mean, if you use any of those and then get comfortable, you'll be able to switch over, and you'll have to learn a couple different things. Like some of the files are in different places, but it's not that big of a deal.
Yeah, but the point I want to get across is those are the three that are used in business.
Yeah.
So don't go learn something that's way different than business and then have to relearn it again for business. Stick with Ubuntu, most commonly used in the cloud. That's why we used it. Red Hat,
Right.
Great operating system. Amazon Linux is based off Red Hat. Oracle Linux is based off Red Hat. So it's kind of like, pick one of the three business ones, Al, and
Right.
that way you're getting transferable job skills.
Yeah.
So
This is something
Angela
that every
asked-
one of us has done.
Angela
Well,
asked if Nathan can cover how to not lock yourself out. That sounds like something I would do.
Well, I mean, I do cover that in the I do cover that in the course. So I mean, essentially, if you lock yourself out, you can boot into an emergency target. If it's Ubuntu or Red Hat, so Ubuntu and Red Hat, I'm going to take just a tiny step back. When the system boots, it initially boots a tiny operating system called an initial RAM disk, and there are technical reasons why it does that. But it boots that, and then from there it boots the entire system and then replaces it. Ubuntu and Red Hat use different initial RAM disk technologies, so the options for you to get into the RAM disk are different. What typically works is when it's booting, you can what you want to drop into is like emergency mode or something, or recovery mode. And then you can reset the root password or your user's password. There are a couple other steps. If it's on Red Hat and there's SE Linux enabled, then you have to take some other steps. There's some documents on resetting the root password for Red Hat that Red Hat has published, and those would be good references. And I think they have a couple different docs covering a couple different methods. But if you some of the Red Hat documentation is behind what appears to be a paywall. You need to log in, but if you go to developer.redhat.com, you get a free developer account, and then you can access their documentation for free. It's a great resource. You should definitely do that.
And actually, I'm going to stop you there for 1 second. I want to get something clear. Does everybody see the level of depth that Nathan just went into this? How the RAM disks are different, how it operates, the architecture of the operating system. That's what separates a real engineer versus a certified person that can't get hired. I hired him. Why? Because he's capable. That level of expertise is so deep. If his expertise was, hey, I can click a few buttons, he couldn't teach those. That's why people get certified and can't get hired in the cloud. In other careers like a CCIE, it could get you a job. But that's because the CCIE, you have to read about 75,000 pages to be able to do it. And that's about the first certification and the only certification that'll get you a job. But, just keep listening to the depth. When you hear us architects talk about the way we design it in the depth, that's what separates it. So I just want you to recognize that and really listen and focus on that, because that's what you're all going to be, those people that we train, because that's what it takes to get hired. And when you have that, anybody will hire you anywhere, anytime.
And I got to interject here and be the business guy. If you want to learn more about how not to lock yourself out, enroll in our program today.
Yes.
Yes. But on a real note, we've got some other questions.
Well, let's get to the Kali Linux question, because that's a really good one.
Yeah, and I've got some to go back to after that.
And I'm going to tell why people Kali Linux should not be the one they choose. So Kali. So the first thing, the second you download Kali Linux, you end up on an NSA watch list because this is a hacker tool, and I am not joking. You literally end up on a watch list the time you download this.
Well, I'm on a watch list then.
I am too, and everybody that I know is because we all.
I think I'm the only one on the call that's not on a watch list.
So
well, then we should encourage people to download it so that the NSA runs out of resources to track us.
Well, okay, that's a good option. But let's stay apolitical on this call. But I just first, from a privacy perspective, when you do this. Yeah. Secondly, Kali Linux is a security operating system. It is used by ethical hackers and non-ethical hackers to hack into systems. So, why would you use the hacker operating system? Go with the standard one that the business are using. Yeah, this Kali Linux and Parrot OS are designed for penetration testers. It's not your career, so focus on your career versus somebody else. Now, if you wanted to be a cloud security engineer, then yes, Kali Linux is awesome.
Right. I mean, I agree with that. That's I'm already on the NSA watch list, so that point notwithstanding, it's correct about if you want to get into security, then Kali Linux. Otherwise, it's not really designed for like anything else. It's not designed for anything else. So
I'm just gonna point out that you probably just both of y'all probably just put our YouTube channel on the watch list. Just gonna say that.
Yeah, I know that to be true. We said Kali Linux.
They already had us on there. So
the second you say Kali Linux, but here's the thing: why are we learning any of these things to improve our careers? So use the thing that is most like your career. And when you train a pro athlete, they train the way they fight, so to speak. You're going to train a SEAL the way they fight. So don't train an operating system that's not going to be what you're going to use for work. It's just not transferable skills.
Yoda said it best: use the force for knowledge and defense, never for attack.
Yeah, that too.
Mike, have you ever watched Star Wars?
No. Okay. But somebody called me Yoda the other day, and I don't know what that means. He said he was okay. Is Yoga a bad guy or a good guy?
Oh, he is the sage, old.
He's the
well-informed. Yeah, Jedi Master. He is the guy.
The question is, were they saying your personality and ability, or the way you look? Because it could go either way.
So I had gotten this person 3 jobs. And
okay.
They have the opportunity to get a big job.
You are the sage. Yeah, you're the top of the mountain guy.
So it's a good thing, not a bad thing, though.
No, not at all.
It's great. It's great.
And if they're talking about the way you look, don't take that from them.
Okay.
Yeah.
Don't take that. Yeah.
Just kick them out the door.
Now, this was somebody I really liked. They were asking about a new job, and they were asking about supply and demand curves. And we had a really deep macroeconomics discussion. It was really cool. And after that, so I was hoping it was okay.
Yeah, it's good. It's good. As long as.
Long story short, yeah. Very high compliment, Mike.
And thank you. You see how much TV and movies I watch. Although I got to say this, I watched the entire Ozark series on my 3 days of vacation. And Chris, you got to tell me what Ozarks are because you're a Mississippian, right?
Man, Mississippi has nothing to do with the Ozarks. Elonzo is closer to the Ozarks than Mississippi is.
Oh, well, and the show was set in Mississippi, and they said that's where the Ozarks were.
The Mississippi River may be close, but no. Ozarks are in Missouri and northern Arkansas.
Oh, that's right, Missouri, not Mississippi. I had the 2 M's
okay, all right, that makes more sense. Yeah, Missouri. Yeah, I was about to say,
what the life of an architect is like? Go to New York, go to LA, go to San Francisco, go to Atlanta, go to Dallas, go to Houston, go to London, go to Dubai, and you never see any place else. It's like, except for I've been to Kansas City a lot.
Yeah. So you've been close to the Ozarks then.
Right. Oh, wow. I have to get there next time.
Yeah. You're about 2 hours north of the Ozarks if you've been to Kansas City.
And I've been to McPherson, Kansas, so maybe I was even closer. And I've been to Iowa, too.
All right. So I'm not sure about this question. Again, I'm not a tech guy, so I don't know what this means.
Oh, this is the saddest thing ever.
It's not that sad, actually. So CentOS 7 still exists. What Red Hat did with CentOS is, and they announced it far in advance, but did a bad job of announcing it, and so then people were surprised and then upset. At a certain point with CentOS 8, they switched it to CentOS Stream. If you want a bit, so CentOS Stream is essentially Red Hat has changed the way that they do the way that they manage package releases into like these package streams, and that's whatever, right? But so they've taken CentOS, and CentOS used to be a bit for bit replacement. I mean, a bit for bit copy of Red Hat. But what Red Hat has done is now they moved it slightly upstream. So it's essentially pre-release. CentOS 8 Stream is essentially pre-release Red Hat. So it's
like you're a beta tester.
I mean, it's actually a very smart decision by Red Hat, because the thing is that like Oracle, which there used to be all these different copy distributions of Red Hat. So there's like Scientific Linux and whatever, right? Red Hat and so what they would do is they would copy the Red Hat source and then build it. Red Hat then was making CentOS, and so then what everybody started doing was copying CentOS source. So Red Hat was doing all the work for everybody, and then and getting nothing out of it, essentially. So what they did is they moved CentOS upstream of Red Hat. So what they have is they have a base of people to test the enterprise product, and it's and it's not unstable. I wouldn't even remotely call it beta. It is essentially, you get it like weeks before it goes to Red Hat, right? And so it's essentially the final fire test to make sure that there's no issue in incorporating into the enterprise product. There's now Rocky Linux, which the guy who originally created CentOS before it got bought by Red Hat has now created Rocky Linux, and Rocky Linux is precisely what CentOS used to be. So if you want a clone of Red Hat 8, I'm pretty sure Oracle still does it, but you can just get Rocky Linux, which is free, just like CentOS used to be.
Well, that's great. It was very smart for Red Hat, because now they've got
Yes.
users to test a release candidate, which is great. But I just love CentOS because it was the most stable thing. I think I had a couple hundred GPUs running CentOS, although having to compile a kernel just to install an NVIDIA video driver, Ubuntu does a friendlier job.
Can we just learn
so
Python and not use Bash scripting?
Sorry, I interrupted you. What did you say to that?
I was just reading that question. I mean, yes, sort of. I mean, the thing is that not my course covers Bash scripting. Bash is I mean, it's a little more like Linux native. There are some dependency complications with Python. If you're good at Python, most likely you're not going to have to do a lot of Bash scripting. If you're interested in Python and Python really gets you excited, you can learn Python, and then learning Bash scripting is going to be pretty easy comparatively. I would say that I mean, Bash scripting is not that complex, and it's good to know a little bit, because the other issue is that a lot of system scripts are going to be in Bash.
Yes.
There are going to be some things that are in Python that you'll find. I would say that if you want to be an engineer and not focus on coding, the two things that you should learn, the two kind of programming languages or scripting languages that you should learn, are Bash and Python. Yeah. Those are far and away the ones that you'll encounter the most. I am now at my new job having to deal with C a little bit. So I have like C, Python, Bash. And C is, I have said I'm not a programmer. It's a cool language. I don't like it though.
But one thing for you, Khalid, if you want to get hired as a cloud engineer, you must know Bash scripting and Python. You won't get hired as a cloud engineer. Now, you may be able to work and function in society, but you've come to us to become a cloud engineer, and you will not be hired without it. And that's why we put it in the course. So please.
I mean, another way of putting that, like my answer is that, like, you should be able to write some bash scripts. It's very functional and very useful, and you should be able to read Python. I mean, and I think that is like, I mean, that's where I'm at. I can write a little bit of Python if I have to, and I can add like debugging to Python if I have to. But the main thing is that I can go through and read what other people have written, and I can debug that way and figure out what a program is trying to do. But I definitely use the bash scripting more. There's a lot of overlap, but I think that bash scripting is probably more useful. But it also, but it does depend. If you're in a mixed environment, like a Windows environment, Python is truly cross-platform. There are a million different situations. We're targeting the most probable. But it is also, you are the architect of your own career, even if you are an engineer. And you have to, there are little decisions you will make, and if you love Python and learn it, it's not going to hurt you. That's for sure.
It'll always, that's great. But like even a bootstrap script for a server in the cloud, all that's done in bash. So it's not possible to work as a cloud engineer without it. Linux engineer, sure, but not really either. But actually, for all those careers, bash is pretty critical. But
and I think the amount of scripting you need all around is pretty rudimentary. I mean, I think I give you, like, in the course, I give you the tools necessary to become far better than you need. But you're going to start out and you're going to be bad, and bad is good enough if you understand kind of how it works and can figure it out. That's what you really need to get your foot in the door.
All right, so it's time that we come to an end, but I want to surprise Mike and Elonzo here. I decided after last week, since I'm MC, I get to decide what's on the show. After last week's show, which I thought was probably my personal favorite show, I decided that every time we have a guest, we'll ask them what one of their favorite books is.
Good idea.
Okay.
Yeah.
That's a nice idea.
So we'll close out the show by asking Nathan, what would you say is one of your favorite books? I know this comes as a surprise.
This is a difficult.
It doesn't have to be your favorite. It could just a favorite. Your current favorite, your all-time favorite, anytime favorite, something that's a go-to that you've read several times. Just something that you find as your favorite book, and then we'll let Mike close out the show for us.
So this is a technical book. It's not reading because of my filter.
Yeah.
It's Algorithms Unlocked by Thomas H. Corman, which I'm trying to get slightly better at coding.
Algorithms.
Yeah, NSA is watching you very closely.
Yeah.
I'm gonna need you to send that to me in Slack so that I can add it to the description.
There we go.
Okay. Algorithms Unlocked. Okay.
Algorithms Unlocked.
That just sounds like heavy reading to me.
Well, and so this guy, along with some other people, wrote like the definitive textbook on algorithms, and it's like super thick. And I was talking to some like CS people, some like programmers on Twitter, and they were talking about coding, and I was like, hi, I'm a coding idiot. What should I read? Should I get this book? They're like, no, don't get that book. Get this book. So this is the book that I've got, and I've started working on it. It's cool. One of my favorite books. There's lots of books I like.
And it doesn't have to be related to your career or training or anything.
Oh yeah. Well, I like lots of weird books, but I like Kurt Vonnegut, Slaughterhouse-Five is a longtime favorite. I really like Kurt Vonnegut. There's Cormac McCarthy, Blood Meridian. It's a crazy book. Is very, very good.
Okay.
I don't know. I think that those are some top ones before I get into like really niche stuff.
I find it interesting. If anybody remembers from last week's show, one of my favorite books, I got the same way that Nathan did. I went online and said, I'm looking for something to, I wasn't looking for anything specific like you were, but I went online and I said, I'm looking for something to read. And I took up a recommendation and it was one of my favorite books. So,
you know, another great book, and this is left field. So my wife paints, and is Hispanic, and so I bought her. Salvador Dali wrote a book called 50. It's like 50 secrets for. I mean, there's different translations. 50 magical secrets for painting, or something like that. And so it's like a weird, surrealistic guidebook to being a painter, and that book is really, really good as well.
Nice.
All right. Well, thanks for sharing. I'm gonna add that to the. I'm gonna go back through the transcript and add them to the description afterwards.
Okay.
Because that's, like I said, that's something I want to start doing with all of our guests. I think that's an interesting thing to do. But I'll let Mike close it out. I'm gonna bring Mike to the
fantastic, and I'm going to answer one more question. Someone asked, how do our classes, the live classes work, and we gave them the time. So it's like we get together on Zoom, and we all have a conversation, and we teach the class, and people, today we taught about virtualization. We worked in VMware ESXi, and then we did some virtual machines and multiple clouds. It was a really great day. Lots of people had a ball. I wanted to thank you all for the show, but I actually am trying to learn how to use YouTube, and I'm told that, if you're having a good time, could you please like, comment, and subscribe? I keep getting texted messages like that, so I know I should ask. Please
smash that like button.
Yeah, smash that like button, please. For those people that want to be cloud engineers, look, this cloud engineering program, I am beyond excited about it. I mean, I was excited when I launched my cloud architect program. And I think we got about 100 people, really great jobs last year. So, that I was pretty excited. And now every day somebody gets hired. And then when we launched this cloud engineering program, I am just so excited because we brought people in like Nathan that are just experts. You can see it. We brought in a lot of other really good people for help. We had a developer write a Python course for us, an intro level to Python course. And let's just say this is a deep course, and people believe in this course and getting their first cloud engineer job. And right now we're offering half off because we want to make it easy for everybody to build your cloud computing career. So right now, I don't know how long we can run it, but we'll be running this 50% discount for the near future. So please sign up while it lasts if you want to become a cloud engineer. Also, on Thursday, we have our How to Get Your First Cloud Architect Job webinar. It's completely free. If you want to get a cloud architect job and you want to know what to learn, what to know, what do the hiring managers want, what should be on your resume, how do you skip those pesky HR people that want to auto-reject you, they'll teach you that on this completely free webinar. If you're trying to pass your AWS Certified Solution Architect exam, we've got a completely free book and course. The links are in the description below. Please check that out. And, thank you so much for coming to this, and also vote for your next boot camp. Do you want the next free boot camp to be Azure, as in like an Azure Solution Architect expert, or a Google Professional Cloud Architect? Let us know. We're going to do a free boot camp in June for you. So vote on the boot camp. The link is in the chat box and the description below. So I hope you had enjoyed our discussion on cloud engineer job training and Linux for cloud computing and Linux as a rule and the cloud. We brought Nathan in. Nathan, thank you so much for coming. Elonzo, my brother, thank you for being here with me all the time. I always appreciate you being here. We'll talk real soon. Yeah. And Chris, thank you so much for coordinating this, hosting this, moderating those questions, and dealing with all that goes to putting a show like this together. So tomorrow is Wednesday. For anybody that has any questions in the morning about their cloud computing careers, we'll be online completely free, answering all your questions from 9 to 11, right, Chris? So we'll be online completely free. Have a wonderful night, everybody. Thank you so much. And next week, we have a really good show. What's our show on next week about, Chris?
I have no clue, but it's going to be fun.
It'll be fun. Okay, we'll announce it soon.
Thanks
we got
a lot,
lots
guys.
going on. We just got through launching a new program, so I don't know. I have no clue what's happening. We're just
It'll be
having
on
fun.
something cool. We've got a lot of people that want to come in. We've got lots of shows coming up, lots of
we got-
CEOs, CFOs,
Yeah.
lots of famous people. They're all going to be sharing their business experience
Yeah.
to help you all build better careers and better lives. So
All right.
thank you all
Bye,
so much.
everybody.
Have a great night. See you
Yes.
soon.